Hi guys. So this is actually going to be the third. I think I don't remember exactly the number, but one of the problems in homework number 4. So I decided to do this as a video clip mainly because it is completely related on to the human body, and it looks little complicated, but you will see that it is not as complicated as it looks. All right, so I'm going to first draw the picture, like right on the paper here. So this black line represents the spinal column, and there you have FE. I don't really have the problem here, only the questions, the two parts, the places where it explains what everything are is not given here. So I am not going to get to that, but please go ahead and read the problem. So this FE is pointed at an angle given in the problem, making a 12 degree with the axis of the spinal column. So I am reading it off of my computer right now so I can see the numbers. You guys go ahead and read it as well. So this angle is 12 degrees, and there is this W, which is the weight, in the problem it says the force of the erector spinae muscle, and Fe actually is the force of the erector spinae muscle, and W represents the weight, and the W is given in pounds. So this is straight pointed down, and that is W. In other words, you can call this the same as Fg, gravitational force, and it is given to us as 90 pounds. Now, if you read the problem further, it says the person is bending over so that the spinal column makes an angle 30 degrees with the horizontal. So I am going to draw the line, the horizontal line here, and this dotted line represents the x-axis, or the traditional x-axis, or the horizontal, the line horizontal to the spinal column, and this angle is given to us as 30 degrees. 30 degrees, and that angle is measured in counterclockwise direction. So to make our lives a little easier, I am drawing this line perpendicular to the horizontal line, because we know W is pointed downward along the negative y-axis, right? So this is what we have. Now I am going to redraw it quickly so that I can make my axis defined and mark the forces. So this black line is the spinal column, and that is Fe, the force on the erector spinae muscle, and W, straight down, that's the weight of the that's the weight given to us of the body. And then I draw the horizontal line like that, and I mark the angles. This is a 30 degree angle, and here this angle is given to us as a 12 degree angle. So let's read the part A of the problem over here. Assume that it is necessary that the pull of the erector spinae muscle results in a force of 55 Newton that will cause the back to rotate. So the back to rotate, so let me actually read highlight this. This line is the back, right? So there is a force. I'm going to draw it using let's say this color, green. This is the force that they are talking about, which is perpendicular to the spinae muscle, and that force is given to us as 55 newtons. Now watch out, one force is given in newtons and the other force, W over here, is given to us as in pounds. So we will have to compare them and convert either of the two to one type of a unit, Newton to pounds or pounds to newtons. Now the question asks us, determine the tension produced by the erector spinae muscle. Now, what exactly does this mean? If you pause the video and read the problem again, this is what it says. Assume that it is necessary that the pull of the erector spinae muscle, which is this, results in a force of 55 Newton that will cause the back to rotate. So the back actually is rotating because of this 55 Newton force. The back is rotating, like let me draw an arrow showing how it is rotating. So basically what it says is that the force on the erector spinae muscle, which is Fe, is producing a 55 Newton force along the y direction to cause the back to rotate. And the wording is the only complicated part. The math is pretty easy here. So in order to answer this question, I am going to take the back as my positive x-axis. This is my positive x-axis, and the direction perpendicular to that is my y-axis. Now, if you take the x-axis as the spinal column, then let's do a table. But before we even go there, we know that 55 Newton force is produced by the erector spinae muscle force, and I am going to get the y component of that erector spinae muscle, and that I am going to set equal to 55 Newton. So let's write it down. The y component of the force on the erector spinae muscle equals to F E Y, and that F E Y equals to 55 Newton. So using this, we should be able to find what Fe is. So we know that the y component always goes with the sign, right? So let's find what it is. Fe and sine. What is this angle? The counterclockwise direction. I am going to again use a different color and highlight that, so you can actually see that on the video. So this angle is 180 minus 12. So 180 minus 12 is 168. So there you have sine 168, and this equals to 55 Newton. So I am going to substitute for 55 here, and then Fe sine 168, and as a result you can find Fe equals to 55 over sine 168. And I would like you guys to go ahead and find the final answer here, and that is the answer for part A. So you will get something like 264.5, and this answer is in newtons because we started with newtons, and the pound was not involved here. Now please go back and check the question. Assume that it is necessary that the pull of the erector spinae muscle results in a force 55 Newton that will cause the back to rotate. So what is the pull of the erector spinae muscle? That is the Fe that you see over here, and it is resulting a 55 Newton force over here perpendicular, so that the back actually can rotate in the counterclockwise direction. So as you can see, the wording is the part that you have to worry about, and let's go back and find out what is said in the second part. How much force is causing compression of the spinal column? Now the compression has to be along the x direction, right? According to the way how all the forces are set up, the compression should be pointed in this direction, we don't know that yet. I mean, when we do the math, we will end up with a negative answer if we do everything right. So let's do the x table. Now at this point we are looking at both forces Fe and W. So this is our x direction, and Fe along x direction and W along x direction. Now please remember W is in pounds, so we will have to convert pounds into newtons. So when I convert 90 into newtons, I get 400.3 newtons. Please check that. And now I am using this 400.3, and since I am looking at the x-axis, I am going to go with cosine, and this angle over here is a 60. I'm actually marking it on the diagram. If you can't see it, this is a 60. So the angle with respect to the x-axis is going to be 240. And then for Fe, we already know what Fe is, so I am using that 264.5 cosine, same angle that we used earlier with sine 168. Now what I want you to do is take the sum of Fx and find the sum using the table and substitute it in here and find the net force along the x-axis. So the sum of Fx that you are finding here is the net force along the spinal column. So when you are doing an activity like this, bending, the force is actually applied as a compression along the spinal column. So here the answer, expect an answer in negative, and that negativeness tells you that is a compression. That is a compression. Okay, so I would like you to complete this problem and submit on the homework, and I'm not going to discuss this again in the class.